Happy Friday, everybody! I am Colleen Parrott with the Space Foundation. I am the coordinator of social media and public relations, and I am here with Leanne. She is one of our space education specialists, and today we're going to be talking about the sun. So don't we love Colorado weather, right? We already had to cancel this last week because of the snow. Today, we're just dealing with a little bit of rain. But last Monday of last week was actually the first day of spring. So the first day of spring is also the day of the vernal equinox. So on the equinoxes, the sun shines directly on the equator for about the same amount of time as day and night. And that begins spring. In the Rocky Mountains here in Colorado where we are, spring means rain and snow. Before we came out here, they're actually forecasting about 5 inches of snow between now and this time tomorrow. So we'll see about that. But to celebrate the vernal equinox, we're going to talk about the sun today. So we've got some fun facts for you, information about our sun compared to other suns, and we've got some great questions from you all. So Leanne, can you tell us a little bit about the sun?
Absolutely. Even though we can't see it today, it's about 4.6 billion years old. The stage of the star is a yellow dwarf, and it is about 865,000 miles in diameter.
Wow, that is huge.
Yes, it's very big. Surface temperature is 9,932 degrees Fahrenheit.
Wow.
Super hot.
So that's really, really hot. Is that like the temperature of the whole thing, or does it change within it all?
It actually gets hotter as you get closer to the core. So the center reaches temperatures of about 27 million degrees Fahrenheit.
Yikes.
In the center. Yeah. It's mostly composed of hydrogen and helium. It's about 70% hydrogen, so that's its main element. It contains about 99.98% of the entire mass of the solar system.
Wow.
So what happens is when all the hydrogen has been burned, okay, the sun's going to continue for about another 130 million years or so, more years, and then eventually it's going to expand and it's going to engulf the closest planets to the sun. So eventually it's going to reach the point where it gets to Earth. Wow. It is about 109 times wider than the Earth and 330,000 times as massive. So one day it will be about the size of Earth after all that helium burns out.
Wow.
1.3 million Earths could fit inside of the sun.
That's crazy. Because we were talking about Neptune last time, and it was something like 300 of Earth could fit in there, and so to have over a million is
right, which is outrageous. And it's still a lot, but over a million Earths could fit inside the sun.
Now I've heard that when Pluto and the New Horizons mission went by, that noon on Pluto, which would usually be the brightest time of day here, that it's only about as bright at noon as it is here on Earth at like dawn or dusk. So how long does it take for the light to reach Earth?
So it takes about 8 minutes to reach the Earth because it is 93 million miles away. So even light, super fast, it still takes about 8 minutes to reach the Earth.
That's crazy. So the sun is middle-aged, right?
Yeah, it's a yellow dwarf star. We call it a middle-aged star. Even though that's 4.6 billion years, that we still call that middle-aged for a star, it has enough hydrogen left to burn for about another 5 billion years. And like I said before, it's a yellow dwarf star.
So talking about it being a yellow dwarf, and earlier you mentioned a red giant. So are there different classifications, kind of like for the planets? We've got, Pluto's right now a dwarf planet, and there's exoplanets.
Yeah, we have different. We basically have star names based on their size, and with our sun being a kind of an average size star, there's actually stars out there that are much, much bigger than ours. But yeah, we have different names for the sizes of stars.
Okay. So we post every Sunday on our Facebook page a happy sun day photo, and they're always different colors. But a lot of times we see the solar flares coming out on that, kind of like we have our starting soon sign here that my executive assistant was holding. So kind of like we see the flashes coming off the flares. What is that about?
Well, because there's so many reactions going on, and all that energy is coming out of the sun at a very powerful force all the time. Sometimes that energy comes out in really strong bursts of light, basically. So that's why we see those solar flares come out. Now, a lot of times we'll see them kind of loop back down. They'll be twisted around. That's because of the strong magnetic field that the sun has.
Okay, very interesting. So what can you tell me about nuclear fusion?
So that is the kind of the key to how stars are formed and how they grow and how they work. So this fusion happens in the middle of stars, just like our sun. So hydrogen atoms, they're going to be fused together to make the next element on the periodic table, which would be helium. So when those atoms are fused together, the energy is basically being pushed out, okay, and it releases the neutrons from these elements. So when they're fused together, those neutrons are basically being pushed out, but the gravitational pull itself is pushing back in on the star. So that energy comes out in form of light and heat, like we get with our sun. And eventually the fusion in the center creates more and more elements and releases more neutrons, and it becomes a greater and greater gravitational force, which eventually is going to take over as that star grows and grows.
That is crazy.
Yeah, so they get bigger and bigger. And then finally it hits its maximum amount, and that gravity is going to take over, and then it's going to collapse in on itself and become a dwarf star.
Wow, that's a lot to deal with for
Yeah,
a star.
a lot of chemistry.
So again, we kind of talked about the classification. You said that our star is actually kind of a medium-sized star. I mean, it's just average. It seems pretty big.
Yeah, it is, and compared to our planets, it's definitely very, very big. But there are other much bigger stars, but there are also smaller stars. We have found stars that are 100 times bigger in diameter than our own sun, and we have also seen stars that are only 1/10 the size of our sun.
That is crazy. So we talked a little bit beginning about we're doing the sun today because obviously there's no sun, but because of that vernal equinox. So is there anything else that you can kind of tell us about what the equinox is, or?
Yeah, so since night and day are nearly exactly the same length, about 12 hours, all over the world the event is called the equinox, which in Latin it actually literally translates to equal night, equi meaning equal and nox meaning night.
That's really cool.
But in reality, the equinoxes do not have exactly 12 hours of daylight. Solstices and equinoxes mark key stages in the astronomical cycle of the Earth. So in a year, there are 2 equinoxes, spring and autumn, and then there are 2 solstices, summer and winter.
Okay, because we hear that sometimes, usually we just hear spring, winter, fall,
Right.
summer. So
Yeah.
there's reasons behind all of our seasons.
Right. So the dates of these equinoxes and solstices aren't fixed due to the Earth's elliptical orbit of the sun, but the Earth's orbit around the sun means that in early January is the sun's closest, known as perihelion, and in early July it's the most distant, known as aphelion.
Okay, that's good to know. So, for those of you who might just be joining us, we are here talking about the sun in rainy Colorado Springs at the Discovery Center here. We're just getting some great information about the sun, and we got some wonderful questions from our viewers. So we have Dave, who's actually a local science teacher here in Colorado Springs, and he wants to know the best website to show solar observatory views. And we've got a couple of those that we found. One is SOHO, and that is the Solar and
Heliospheric
Observatory. Definitely not why I'm a scientist right there. But it's actually a project between ESA, which is the European Space Agency, and then NASA, the one we have here in America. And we'll share the website for that one in the comments, as well as the other, which is SDO, which is the Solar Dynamics Observatory. And that was the first mission from NASA to really design to understand how the sun interacts with us here on Earth. Then Michelle from Mississippi asked us, if it weren't for the sun, how cold would it be on Earth? And I mean, without the sun today, it's pretty cold. I mean, my hand is a little freezing right now.
So this is something that scientists can't predict for certain, but they can estimate a few things happening. So if the sun were somehow turned off, which actually isn't physically possible, the Earth itself would stay warm for another few million years. But anything beyond that, we're not too sure of. But anything on the surface, humans, animals, would start to feel the change within a week or so. So within a week, the global surface temperature would drop below 0 degrees. Without the sun's rays, all the photosynthesis on Earth would stop. Obviously, we need to have the sun to have photosynthesis, so anything that relies on plants for food, including humans, would actually die off, unfortunately.
That's awful.
Within a year, the top layers of the oceans would freeze over, and then a few thousand years, the global temperature would reach negative 400 degrees Fahrenheit, which would kind of be stable at that point. And then the atmosphere would have frozen and fallen to Earth, so leaving anything alive exposed to all the harsh radiation that we have out in space. So life would cease to exist if the sun ever turned off.
I personally am a sun person. I like the sun, and that makes me even more thankful to have it, because it's probably only in the 40s today, so I mean, it's really not that cold, but it's not negative 400, and I'm already cold. So Preston also sent us a great question. He wants to know why he can watch sunrise and sunsets, but any other time the sun, and he quotes, burns his eyeballs.
So that's actually a great question, because it's a very common mistake that people make. So when the sun is in times of low light, like a sunrise or sunset, it is true it might not seem like the light hurts our eyes as much, because it's being filtered through so much more atmosphere, but it's actually just as harmful to our eyes during that time. So it's similar to like when you go outside and it's cloudy, sometimes you don't think, oh, I don't need sunscreen today, but we still do. It's kind of similar to that. So the sun's rays are harmful to our eyes no matter what the time of day we look at it. It's just the atmosphere that makes it seem less painful to our eyes.
Huh. Very interesting. I didn't know that.
Yeah.
And that is a great thing for us to be talking about right now, of the danger of looking at the sun, because we have a full eclipse coming up this summer. I believe it's in August.
Yes.
So what suggestions do you have? Because, at the same time, we're not supposed to go out and look at the sun with an eclipse, even though it's shadowed.
Right.
It's still not good. So what can we do to view that?
Yeah, well, we're definitely looking forward to that around here at the Space Foundation. They do have, certain types of glasses that you can buy that help protect if you really want to get a good view. But a very basic design that is great for anybody to do is, if you have a sheet of white paper down on the ground, hold up a piece of cardboard with a hole cut in it, and just hold that over, and you can basically see the eclipse right there on your sheet of paper, and you don't even have to look into the sun. So there's some good projects out there. It's a good thing for people to research how to do.
Awesome. And for some of you may not know that the Space Foundation also has a Pinterest page. So we'll be making sure to get some pins on there of things you can do at home. And if you're local here in Colorado, I'm sure we're going to be doing some events that day. So it should be really cool. They don't happen very often to have a full one like that. So our next question came from Ariana. And she wants to know, do meteorites or asteroids ever get close to actually hitting the sun? Because we know that they'll probably, burn up and fizzle before they hit there. But, is there any time they actually get close enough and make it?
So no asteroids have actually ever been observed to hit the sun, but that doesn't mean that they don't. It's just maybe ones that we don't see. Asteroids are normally content to stay in what we call the asteroid belt, which is between Mars and Jupiter.
Okay.
But occasionally something will nudge them out of their orbit, and then they come flying into the sun, and they might even make it there. So sometimes, when we see a shooting star, that's what we're seeing, burning up.
Okay, interesting.
So once they arrive on their way towards the sun, so you might think that they should be guaranteed to hit the sun, but that's not always the case. It's actually difficult for something that is orbiting to fall in the way of the sun because of property of orbiting objects called an angular momentum.
And that, I actually took a class. We had some folks from Lockheed Martin come about a year and a half ago, and that's a lot of physics. And
yeah, I don't know much about it.
I still don't fully understand it, to be honest, because there's a lot that goes into it, but it's kind of the whole, if you throw something up, the Earth's gravity is going to pull it down, so you kind of got to get it up just enough to get it into that orbit. So It's really interesting concept, but I know it wasn't really the easiest thing for me to understand.
Yeah, definitely. So the SOHO satellite has detected more than 1,100 comets known as sun grazers. These are comets that get close enough to the sun to glow very brightly and show up in the images, while the others might disintegrate. So we call those, a close call, and those are going to sail back out into the solar system and until the next orbit brings them back in.
Okay, so it's kind of like the slingshot they do sometimes with satellites. They'll send out to other planets to kind of get that slingshot motion to help them out. So we have one last question today, and that is from Sherry, and she wants to know, what color is the sun?
That's a good question. We see a lot of students are always going to draw their sun yellow, but it's a common misconception that the sun is yellow, orange, or even red. But the sun is essentially all colors mixed together. So that appears to our eyes as white, and it is easy to see in pictures from space. And scientific instruments can sometimes detect that light in that our eyes cannot detect. So when people want to look at those, say like X-ray or ultraviolet images, they need to color them, something like our eyes cannot detect. So scientists kind of pick some bright color, a color that would never be confused with viewing the sun in white light, so that way we know the difference between seeing the sun in a picture versus what our eyes are seeing. So that non-seeable version of light, like in X-rays, that's going to be different than the color that they've chosen. So it's hard for many people, even scientists, to admit that the sun they are used to still living with is actually white. So sometimes they even color pictures of the sun taken in visible or white light to get more like something we would expect, and that's kind of where we get that yellow, orangish, reddish color.
And like some of the odd colors, the purples, the pinks, the greens, even and some of the blues. For those of you who follow us, the Space Foundation, on Facebook all the time or on Twitter, we post those, Sunday photos that I mentioned, and a lot of times they're different colors, and that's the different lights they use help us to see them in different colors and see different things that maybe we couldn't. So it's really, really kind of cool to think what all is there. So that is what we've got for today. Thank you so much, everyone, for tuning in. We had some really great questions, and we always appreciate it. Now, be sure that you turn on notifications for when we go live, because the next time we're going live is actually going to be next Friday. We're going to be live from the Broadmoor Resort and Hotel in Colorado Springs for the 33rd Space Symposium, and we're going to be talking about Jupiter. So it's going to be fantastic. So get your comments for Jupiter ready. Put them in the comments below, and we will see you next week. Signing off is Leanne, Colleen, and my pet assistant here, Snickers. Have a great weekend.